For this reflection, I mainly focus on AlGhamdi's study on using prompt-based large language models for automated scoring and feedback in higher education. I'll briefly reference a couple of other related papers, but this one really anchors the argument I wanted to make. What stood out to me about this paper is that the authors aren't just asking, can we predict something about student work? They're asking, can we evaluate it and respond to it in a way that resembles what instructors actually do? And that shift is really important for understanding why they chose a transformer based model rather than something like an SVM or an LSTM or a feature based NLP pipeline. If this were just a classification problem, like assigning a score category um, or something like that, early approaches would probably be enough. But that's not the task here. The task here is to read open ended student work, apply a rubric, and then generate feedback that's coherent, targeted, and pedagogically meaningful. That's where transformers start to make sense. Unlike feature based models, which depend on us deciding in advance what matters in the text, transformer models assume that meaning comes from relationships across the entire response. It lets the model weigh different parts of a student's writing at the same time rather than processing it step by step or collapsing it into a fixed set of features. And when you compare it to LSTMs, which still process text sequentially, transformers don't privilege the order in the same way. They're built to model global relationships, which is exactly what you need when you're evaluating longer, more complex submissions. What's interesting in this paper is that the authors don't retrain the model to do different tasks. Instead, they change the model's behavior through prompt design. They test whether the model should score first and then give feedback, or generate feedback directly, or decompose the task into steps. So the model here isn't just the architecture, it's the interaction between the prompt and the representation the model already has. That's where you really see the shift away from feature engineering and towards foundation models. The same pre-trained model can score, explain, and generate feedback without hand designing features or task-specific retraining. The representation is already there. The prompt just activates different parts of it. But the paper also carefully explains some of the limitations, and that's pretty important for us to consider. They show that scoring errors are larger for lower quality submissions, which is concerning because those are often the students who most need clear feedback. And because the system is prompt based, small design choices can have outsized effects on the output. This also changes the role AI plays in educational practice. We're not just using models to analyze data after the fact now. We're starting to place them inside the learning process where they interact with students through language. Supporting work shows that this can shape student agency in both positive and negative ways depending on how it's designed. So for me, the key takeaway is transformers are being used here not because they're most accurate classifiers, but because they support a different role for AI, one that moves from prediction to interaction, from features to representations, and from analysis towards participation in teaching and learning.